For this question, just from the look of it, there's no way that you could imagine that it will lead to a quadratic. Okay, but it doesn't really matter. We could start from the definition. Well, obviously, we know that log a plus log b equals to log ab, right? But it must be under the condition that they are in the same base. But in this case, we're fine. So now we could combine them. And obviously now you can tell it looks like a quadratic. If you look at this, just go back to the basics of log. Log base a of b equals to c is actually the same as a to the power of c equals to b, which gives us this. So now we have a handsome quadratic, which gives us these two numbers. But for the case of -1/4, we have to reject this. Why? Again, when we look at the log, from previous example, we know that this part cannot be less than or equal to 0 because the domain of log has to be positive. On the other hand, the range of a log function can be positive, can be 0, can be negative. So if I put -1/4 back into the equation here, this will be less than 0. Also this part actually. So it must be rejected. Now this question is a little bit different from the previous one. If you look at the two log terms, they have different base. So in this case, they cannot be combined, right? So what do? You still try to identify the basic unit. Now in this case, maybe log base 3 of x, maybe log base x of 3. Why do you think so? Because you see a 27 here and a lot of 3's here. But if we take this as the basic unit, it's good because it's already here, right? All we need to do is just to convert this in terms of log base x of 3. Now here's a special formula that we often forget. Log base a of b, we could actually make this into a fraction of log base c of b over log base c of a. And it's a good one because it's very flexible. We could pick any common base that we like, okay, as long as the base is greater than 0. Then we could actually rewrite this into a fraction like this. Now, what base should we pick? Well, because we've identified this as the basic unit, and so we must pick x to be the base, the common base, using our formula here. And for the top part, x to the what power equals to x? And obviously this is 1. And for the bottom part, it becomes this. And why do I want to break 27 into 3 to the power of 3? Because this is to stay consistent with the basic unit, which is this, and it has a 3 in it. And then this 3 can actually be moved to the front, right? Which gives me this. Now what? We can start combining. So if I let star equals to this, that gives me this. Then I find a common denominator, and this part becomes 9 star squared, which leads to this proper quadratic. And so star equals to 1/3 or 2/3. And back to the substitution. So x to the third equals to 3, and x to the 2/3 equals to 3. And then I apply the power on both sides, which gives me these two numbers.